Alright, so today we're going to talk about exponent rules. Part 2. Again, we've been doing this, and this is a rule of equivalency, and we want to back up and remind ourselves of some of the exponent rules. Most importantly, that if you have x times x times x, and you do that n times, or have n factors of x, then you have x to the n power. It is a shortcut notation for writing x times itself n times. So if I have x times x times x times x, 4 x's multiplied by themselves, it's x to the 4th. Likewise, if I have 7 x's, I have x to the 7th. Something we've been doing, should seem pretty straightforward. And then we enter the product rule, where it said if I have x to the m power times x to the n power, the bases are the same. They're both x. They could be both y's, they could be both 4's, they could be both 3's, they could both be 29's. But when you multiply bases, x to the m, x to the n, multiplication here, then you add the exponents, x to the m plus n. So if I have x to the 6 times x to the 4th, I have 6 x's and 4 x's, well that makes 10 x's, or I can simply add the exponents, 6 plus 4. Here I have another example, x squared times x cubed. 2 and 3 more make 5. We also know that when we have x, it's x to the 1 power. 1x here, 1x here, they're equivalent. And then our other rule we learned just a little while ago. When I have a negative exponent, that is like division. I actually have to move that to the bottom of a fraction, 1 over x to the n, where x can't be 0, because we know we can never divide by 0. So if I have x to the negative 3 power over here, I move it across the fraction line, it becomes 1 over x cubed. If I have 1 over a to the negative 2 power, I move it to the top, it becomes a squared. And that 1 is still here, but 1 times a squared is a squared. Finally, we learned that x to the 0 power is 1, or b to the 0, 1, 100 to the 0, 1, 1 million to the 0, 1, negative 10 quantity to the 0 power, 1. Everything is 1 when raised to the 0 power. So, we have these rules, and that's great. Because if we take and you can pause the video, you should be able to figure out all 6 of these examples. Well, the first one, again, using our rules, there's a couple ways to think about it. One way you could do it is bring it to the top, right? And you know what? Change a sign. So I have x7, x negative 3. Now I can use the product rule. Well, that becomes x to the 4. And here's another example, y4 over y2. Well, since this is one term, and this is one term, I can do this. I can say this is equivalent to yy over yy. I have multiplication in top and bottom, therefore I can do cancellation, and I get y squared. But what I want you to do with the last 4 is see if there's a pattern, see if you notice something, to go a little quicker here. I have a to the 11 on top, a to the 8 on the bottom. We know it's going to become negative 8 when we bring it up. Well, 11 plus negative 8, or 11 minus 8, well, this is a cubed. If I go back up here, z8 over z6. Well, I think if you start thinking about this, this is z squared, because this comes up and becomes negative 6. 4 minus 8, negative 4. And finally, I have b4 over b4. Well, that's exactly the same, so it's got to go to 1. But if I bring it up, 4 minus 4, that's b0, and we know b0 is 1. So, we got this. So this brings us to a new rule to put on our sheet. And it's called the quotient rule, because a quotient is answer to division problem, and I have a division problem. I have x to the m over x to the n, and I can't stress enough, it's one term. And when you have x over m, xn, we realize by bringing x to the n to the top, we can have this step in the middle, which we don't need, but I want to show you. And when we have x to the m, x to the negative n, we can use the product rule to get to the quotient rule, which is I can subtract the exponents. The fraction line really is almost like a subtraction sign for exponents. X to the m minus n. And again, if I move that to the bottom, the signs change on m and n. Positive n becomes negative m. Negative n becomes positive n. And I can rewrite those. And again, you can pause the video and write this into your notes. But we're going to apply this now. And I have Three examples here. We know it's x to the m over x to the n, and it's m minus n. So 6 minus a minus 4. Well, we also know that double negatives are a positive, so this becomes x to the 10th power. On the next hand, I have x to the negative a over x to the b. Again, negative a minus b, they're not like terms, so believe it or not, that's as simplified as this can become. It's just taking a look whether they're numbers or values, variables, it doesn't matter. On the bottom example, I have three different variables, and we know we have to combine by like variables. So I'll start with the x's. I have x to the negative 5 on top. I have x, or x to the 1 in the bottom. Negative 5 minus 1. Well, I think that's x to the negative 6. Y to the 6 minus y squared on the bottom. 6 minus 2 is 4. Finally on the top, I have z to the 1 minus a minus 3. 1 minus a minus 3, 1 plus 3, z to the 4th. And I can't stress enough, there are a bunch of ways to write this answer. If I wanted all positive exponents, I can move x to the negative 6 to the bottom right. y4, z4 over x6. Now they're all positive. I can write them all negative exponents. I can leave x to the negative 6 on top, and I can move these two to the bottom and change the exponent sign. And again, I can't say it enough times. This is one term, so we're allowed to do this. I can't do this across multiple terms, and I'll show you an example of that in a second. So the last one, why don't you pause the video, give this a shot. When we come back, all I'm going to do with the top one is do the example. And all I'm going to do on the bottom one is prove that there's nothing you can do on the bottom one. Alright? So, why don't you pause the video, try the top. Alright, so here I go on the top. I have M3, M2. There's a product rule to start with. I'm going to write that as, and I love having an eraser board, M5. Now I have M5 replacing M3, M squared, over M negative 2. 5 minus a minus 2 is M to the 7th. P to the 3 over P to the 4. 3 minus 4 is P to the negative 1. Z to the 10th minus a minus 6. Z plus 10 plus 6 is 16. And then the last one, D to the 1 power minus a minus 2, or D to the 3rd. And again, I often write these as positives, and your quizzes often ask for them to be positive. So I would write it that way. Both of these are correct. We have lots of answers. I just want to take 1 second to show you on the bottom problem, there's not much to be done. You have to put on blinders and look at each term. And if I put blinders on and only look at the left side here, x cubed over y, there's nothing the same there. If I bring this up so that it's an equivalent expression, I can write this x cubed y negative 1 for the first term by bringing y to the top. On the other one, I'll bring x cubed to the top. So I have the minus sign, stays there, negative, and I'll bring that up, x cubed y. The only thing I can do now is look at these and say, is x cubed y negative 1 and negative x cubed y like terms? The x cubes might be the same, but y negative 1 and y to the 1 are not. And we are done. There is nothing that could be done with this. It could be left even in this format. We could have just moved the x3 to the top and wrote x3y, and everything would have been positive. Either way, you cannot combine the exponents because it's not multiplication. It's two terms, not one. And the terms themselves are not the same, so they cannot be combined. Exponents are a shortcut. We work with equivalency from our rules. Takes practice. Keep at it.